Hello friends, in this session we will see what is meant by prime numbers and why they are called so and what is their importance. So for what is to know about the prime numbers, first of all, just we will recall that we have seen that factors means the perfect divisors of the numbers, and now we are going to do one thing, that we are listing down the factors of numbers from 1 to 10 one by one, and we will find out how many factors each number is having. So I am writing here the number, then we will write down the factors of that number. We'll write down the factors of that numbers, and we'll find out the quantity of factors. How many factors that number is having. Quantity of factors. So we'll start with 1. 1. Well, what is the divisor of 1? The divisor of 1, perfect divisor, is 1 itself. So we are having only one factor for 1, and that is 1. So quantity of factors is 1. Now we will go for 2. Well, 2 is having two divisors, 1 and 2. So number 2 can be divided by 1 and number 2 perfectly without leaving any remainder. So we get the quantity of factors being 2. Now let us go for 3. Number 3 can be divided by 1 and 3. So how many factors we are having? Here also we are having 2. In this case we are having 1 and 2. Now we'll find out about 4. Well, 4 can be divided perfectly by 1. It can be divided by 2 also. 2 to the 4. And we are having next as a 4, because the number divides itself without leaving any remainder. So number of factors in this case we are having 3. Now we'll go for 5. 5 can be divided by 1. Yes. What about the other number? Find out any number that can be that can divide 5 without leaving any remainder. After 5, 1. Well, after 1 we are having only 5 as the number which can divide the 5 perfectly. And in this case also we get number of factors as 2. What about 6? 6 can be divided by 1, 3, and after 3 we are having 6 as a divisor of 6. So in this case we are having number of factors as 3. 7. Well, 7 can be divided by 1 and 7 itself. 1 and 7. So number of factors again we got 2. What about 8? Well, 8 can be divided by 1 also, 2 also, 4 also, and 8. So in this case we are having now 4 factors. 9. 9 can be divided by 1, 3, and 9. Number of factors are 3. What about 10? 10 can be divided by 1, 2, 5, and 10. So 1, 2, 5, and 10, they are the exact or perfect divisors of 10. They do not leave any remainder behind them. So we got the number of factors in this case as a 4. Now, what is so different in this case? Well, you will see that there are few numbers which can be divided either by 1 and the number itself. For example, number 2. It can be divided by 1 and 2 itself. Then we are having 3. It can be divided by 1 and 3. We are having number 5, which can be divided by 1 and 5 itself. No other number can divide 5. Well, we are having next number as 7. Next number 7, which can be divided by 1 and 7. So a number can be divided either by 1 or the number itself. So all these numbers, they are having only 2 factors, that are the 1 and the number itself. Now such numbers are known as the prime numbers. Why they are known as the prime numbers? What is the meaning of prime? The meaning of prime means the head, the one which cannot be cut down, which cannot be defeated. It is taken from it's like a prime of, say, a soldiers, a unit of soldiers. So same case, these numbers cannot be divided by any other number. They can be either divided by uh, one or that prime only, that number only. So they are known as the prime numbers. What about one? 1. You can see that 1 is having only one factors and we cannot say it as a prime number. Okay, so what is the name for other numbers such as 4, then 6, then 8, 9 and 10? Well, these numbers can be divided by more than 2 factors. They are having divisors as, for example, we take the example of 4, it is having divisor as 1, 2, 4. You may take the example of 8, it can be divided by 1, 2, 4 and 8. These numbers, they are known as a composite numbers. Why they are known as composite numbers? Well, I will write down the spelling of composite. Composite. The spelling of composite comprises from compose. Compose means they are made up of. What they are made up of? Well, they are made up of multiplication of prime numbers. Means prime numbers are the building block for composite numbers. Well, see like this. See, I can show 4 as a multiplication of 2 and 2. And we are having 2 being the prime number. 2, 3, 5 and 7. They are the prime number from 1 to 10 only. Well, we are speaking about the prime numbers from 1 to 10 only right now. We will see about how to find the prime numbers. After 10, we'll see one more method for that. But we, for the time being now, we can show number 4 as 2 multiplied by 2, and both 2 and 2, they are prime numbers. Let's go for 6. 6 can be shown as 2 and 3, 2 multiplied by 3. Well, it is again 2 and 3, they are prime numbers. Let us go for 8. Well, 8 can be shown as 2 multiplied by 2 multiplied by 2. Again, all the numbers are prime numbers. So 2 multiplied by 2 as 4, 4 multiplied by 2 is 8. So 8 can be shown as 2 multiplied by 2 multiplied by 2. What about 9? 9 can be shown as 3 multiplied by 3. Again, 3 and 3 both are prime numbers. What about 10? 10 can be shown as 2 multiplied by 5. So you can see that these composite numbers, they are composed of product of either the prime numbers or the product of prime number and another composite number, the previous composite numbers. Actually, I have written down all the numbers which are composite numbers 4, 6, 8, 9 and 10 as a product of prime numbers. This is being known as a prime factorization of that number. Means now we have find out what are the only the prime factors of that number, and we have written the number or shown the number as a product of these prime numbers. So you can see that 4 is shown as 2 multiplied by 2. Both are prime numbers. 6 being shown as 2 multiplied by 3. Well, I can show the 6 as 1 multiplied by 6 itself. But the 6 is again a composite number. So I have shown it as a 2 multiplied by 3. 8 can be shown as a 2 multiplied by 4. But 4 again, 8 can be shown as 2 multiplied by 4. So we are having 4 again a composite number over here. But well, I have simplified it as a 2 multiplied by 2 multiplied by 2. And that will become as a 8. And that will form a composite number. So writing a composite number in the product of its prime factors, these are now known as the prime factors. We are showing the number as a product of prime factors is known as a prime factorization. So one thing is clear that the numbers which are having only 2 factors or that can be divided by the same numbers are known as the prime numbers. While rest of the numbers, they are composed of prime numbers and known as a composite number. Now let us go to find how to find the prime numbers from 1 to 100. In this session, we will go how to find out the prime numbers easily when you are given a set of numbers, or rather than set of numbers, a sequence of numbers. Well, this method was proposed by a Greek mathematician known as Eratosthenes, and this method is known as a sieve of Eratosthenes. What is meant by sieve? Sieve means to separate out, a filter. So in this method, we are going to filter out all the prime numbers. This method is basically based on removing all the composite numbers and keeping all the prime numbers. That's why it is named as sieve of Eratosthenes. It was a Greek mathematician, Eratosthenes, who was the follower of Pythagoras. He was known as a Pythagorean. Okay, he was a follower. He was a shishya of Pythagoras. He was actually working as a librarian over there, but he was interested in mathematics and he developed his skill in mathematics. Okay, now in this method, what we are going to do is we are going to write down the numbers, a sequence of numbers in grid. For example, I have written the numbers from 1 to 100. So we are going to find out prime numbers from 1 to 100. So first thing first, we are going to cut 1 because 1 is neither a prime number nor a composite number. It is having only one factor as a 1. We are having next number as 2. And we know that the 2 is a prime number. It has only two factors, 1 and 2. What is the next number? It's a 3. It's also having only two factors, two divisors, 1 and 3. So 3 is also a prime number. What about 4? Can 4 be divided by any other number rather than 4? Yes, 4 can be divided by 2. So we will going to cut the 4. Now, as we have find out that 4 can be divided by 2, means every even number can be divided by 2. So what are the even numbers? Even numbers are the numbers having even digit at one's place. So we are going to cut out, means we are going to sieve them, remove these all the composite numbers by crossing them. So here I crossed 4, then I am going to cross 6, 8, 10. We are having 12, 14, 16, 18 and 20. I am going to cross out all the even numbers. 22, 24, 26, 28, 30, 32, 34, 36, 38 and 40, 42, 44, 46, 48 and 50. What are the next numbers we are having? That are 52, 54, 56, 58 and 60, 62, 64, 66, 68 and 70, 72, 74, 76, 78 and 80. All these are the composite numbers because they can be divided by 2. So they are having factor other than the number itself. So that's why we are removing them. So here I have removed all the even numbers which can be divided by 2. Now we are having 3. 3 is a prime number. So we circled it. We circled 2, it's a prime number. We circled 3, it's a prime number. Now all the numbers which are in a table of 3 can be divided by 3. So we are going to cross out all the multiples of 3. So 3, 6 already we have cut. We are having 9. We already cut 12. We are having 15. We are having 18. Then we are having 21. 3 7s are 21. Then we are having 24 already. It was crossed. Then we are having 27. 9 3s are, or 3 9s are 27. And we are having 30. Okay. We will not stop over here because we are having the multiples of 3 over 3 10s also. 3 11s are. 3 11s are 33. Then we are having 36. Then we are having 39. Okay. Then we will go for 42. But 43 already it is crossed. Then we are going for 45. 48 already crossed. We are having 51. 5 plus 1. We are having 6. 6 is in a table of 3. So 51 is divisible by 3. So we are going to cross 51. Then we are having 54 and 57. 57. 5 plus 7. 12. 12 is in a table of 3, so it is divisible by 3, so we are going to cross 57. Then we are having 60. After 60, we are having 63, 66, and 69. So I also crossed the 69. After 69, we are having 72. Because 7 plus 2, 9, and it is divisible by 3, but it's already cut as an even number. We are having 75, and after 75, we are having 78. It already it was crossed. Now we go for 81. 8 plus 1. 8 plus 1, so it's 9. And 9 is in table of 3, so 81 is divisible by 3. So we are going to cut 81. 84 already cut. We are having 87. 8 plus 7, 15. 15 is divisible by 3, so 87 is divisible by 3, so we are going to cross it. Then we are having 90. Then we are having 93, which is in a table of 3. 96 and 99. So we cut all the multiples of 3 from 1 to 100. Now, 4 already we are having crossed, so 4 is not a prime number, it's a composite number. We are having next 5, which is the next prime number, so we are going to circle it. So next prime number is 5. Now we are going to cut all the multiples of 5 because they will not be now the prime numbers. They are the composite from 5. So the numbers which are ending with 0 or 5, they are divisible by 5. Which are those numbers? 5, 15, 25, 35, 45, 55, 65, 75, 85, and 95. So all these are the composite numbers. Again, all the 10, 20, 30, 40, 50, they are table in a table of 5. So they are crossed out as the even numbers. So next we are having next prime number, which is 7. We circle it. 7 is circled because 7 cannot be divided any other numbers. We are having 1 and 7 as a divisor, so it's a prime number. Now we are going to cut all the multiples of 7. 7 ones are, then we cut 7 to the 14, 7 3s are 21, then we are having 28, then 35, then 42 already cut, 49, here we are cutting 49, then 56 already cut, then what is the next? 7 8s are 56, 7 9s are 63 already cut, 70 already crossed. Now we will not stop here, we will go for multiples of 7 for next also. We are having 77, which is divisible by 7, so cross it. After 77 we are having 84 already crossed. After 84 we are having look at this 91. You may get confused that 91 may be the prime number, but not. 91 can be divided by 7, and when we divide 91 by 7 we will get 13 as a quotient and 0 as a remainder. So 91 is also not a prime number. So we cross the 91. Okay, what to do next? We are having next prime number. Already all the composite numbers we have crossed. What is the next prime number? Is 11, and we will find out any multiple of 11 is remaining. For example, 11, 22, 33, 44, 55, 66, 77, 88, and 99. They are already crossed. What about 13? We'll see the multiples of 13, any remaining, and we'll find that no multiples of 13 are remaining from the cross. For example, 13, then we are having 26, then we are having 39, then we are having 52 already cut, then we are having 65 already cut. So all the multiples of 13, they have already been cut, so they are already been crossed. Even after 65 we are having 78, so 78 is also crossed. So what we have find out is that now what left are the only prime numbers. What are the numbers that are not crossed? Now circle them. After 13 it is 17, 17, then we are having 23, then we are having 29, we are having 19 also, then we are having 31. So So 11, 13, 17 and 19. Then we are having 23 and 29 and 31, and now we are having 37. 41 and 47. They are also circled. In between 51 to 60, we have only one prime number, that is 53. Even we are getting second one, 59. And now next we are having 61. Then we are having 67. And then we are having 71, 73 and 79. Okay, what is the next? We are having 85, 83 and 89. And the largest two-digit prime number is the 97. The largest two-digit prime number is 27. Now we will count how many prime numbers are there from 1 to 100. There must be only 25 prime numbers from 1 to 100. Which are those? Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 1 is a remaining. One number which is not circled, that is remaining, and will be the prime number, that is 43. So we got all the 25 prime numbers from 1 to 100. So we will list down all the prime numbers from 1 to 100. 2 being the smallest prime number and only even prime number is the 2. We are having 3, we are having 5, we are having 7, we are having 11, we are having 13, then we are having 17, and we are having 19. After 19, we are having 23, we are having 29, 31, 37, and then we are having 41, 43, and 47. Then we are having 53 and 59. And then we are having 61 and 67. Okay, then 71, 73, and 79. And then we are having 83, 89. And the only prime number from 91 to 100 is 97, and is the largest two-digit prime number. So all these 25 numbers, they are prime numbers from 1 to 100. One thing is to be noted that, as we can see that, what is the difference between 11 and 13? It's of 2. Such prime numbers which are differing by 2 and coming one after another, consecutive, one after another, they are known as a twin prime numbers. For example, you can see that 11 and 13, they are differing by 2 and they are known as a twin prime numbers. 17 and 19, they are also a twin prime number. Then we are having 41 and 43 as a twin prime number, 71 and 73 as a twin prime number, even 59 and 61, they are the twin prime numbers. Now, we will see one more concept which is known as a prime triplet. What is meant by prime triplet? In a prime triplet, there are 3 prime numbers which are coming one after another. First 2 prime numbers, they are having a difference of 2. And the next 2 prime numbers, means third and fourth, they are having a difference of 4. So we are having one example over here. 11 and 13, they are having a difference of 2. And 13 and 17, they are having a difference of 4 now. So we can say that 11, 13 and 17 is a prime triplet. 11, 13, 17 is a prime triplet. One more prime triplet which we are able to see is 41, 43 and 47. 41 and 43, they are differing by 2, and 43 and 47, they are differing by 4. One more hidden, which is prime triplet, actually is not visible, but maybe can be find out by just looking at very carefully at it, is we are having 70, 67, 71 and 73. This can be said as a prime triplet because first number, they are having a difference of 4, and then second is having a difference of 2. So this is about the prime numbers by using Sieve of Eratosthenes. Well, this idea of finding the prime number can be extended not only from 1 to 100, we can extend it from any number to any number. We are extending the idea of Sieve of Eratosthenes for finding out the prime numbers from now 101 to 150. For first, I have listed all the numbers from 101 to 150 in the form of a grid. Then, now we are going to cut down all the even numbers because they are in a table of 2. So all even numbers I have cut down. Then we will find out the multiples of 3. The first multiple of 3 in this case is 102. After that, it will be 105 because 1 plus 5 will get 6. So this is the multiple of 3. So we are going to cross it. Then we are having next multiple as 108. Then we are having 111. You can see that 1 plus 1 plus 1 is 3 and it is divisible by 3. So I am going to cross it. Then we are having 114. Then we are having 117. Which is also in a table of 3. 1 plus 1 plus 7 becomes 9. So it is divisible by 3. We are having next as a 120. Then we are having next as a 123. 1 plus 2 and plus 3 will become 6. And it is in a table of 3. So 123 is divisible by 6. We are having 126 next. And we are having 129. So we are going to cut 129 also. Because it is in a table of 3. Or a multiple of 3. We are having next as 132. We are having 135 as a next. We'll add 1 plus 3, that will become 4 plus 5. That will become 9. So it is also divisible by 3. 138 is the next possible multiple of 3. And we are having 141. 1 plus 4, 5 plus 1, 6. So 6 is divisible by 3. So 141 is also divisible by 3. So we are going to cut it. Then we are having 144. Then we are having 147. 1 plus 4 is 5. Plus 7 we are getting 12. 12 is in a table of 3. So this number is divisible by 3. And after that we are having 150. Okay. So we have crossed all the multiples of 2 and 3. Now it's time for crossing the multiples of 5. Multiples of 5 ending with 5 and 0. So I am crossing all the multiples of 5. Multiples of 5 which is ending with 0 already cut as the even numbers. Now what is next? We are going to cut all the multiples of 7. It's a little bit tricky because finding the multiple of 7, so we have to go to actually find out, divide it. Okay, 101 cannot be divided by 7. 107. 107. If I divide 107 by 7, I will get 37 as a remainder. And if I try to divide 37 by 7, then I will get a 2 as a remainder. So it cannot be divided by 7. What about 109? Can it be divided by 7? Let us try it. So 109 divided by 7. 7 1 is 7. What remains is 39. And 39 is not in table of 7. So it's not divisible by 7. What about 113? Whether it is divisible by 7. So 113. What left is 43. 43 is not in table of 7. So it's also not divisible by 7. 119. We get 49 as a remainder. And 49 is in a table of 7. So 119 is divisible by 7. Now we are going to add 119 plus 7. What is 119 plus 7? 119 plus 7 is 126. It is in the table of 7. Now we are adding again 7 in it. We get 133. So 133 is also divisible by 7. Okay. Now after that 133 we will add 7 in it. We get 140. It is in a table of 7. It already crossed. And 147 already crossed. So now we will try to find out any number which can be divided by 11. We will go for try for this. No, this is not divisible by 11. Not. This is also not divisible by 11. Whether this is divisible by 11? No. Any other number that is remaining? Yes, 121. It is in a table of 11. So we will cross it. Now we'll go for 132. It's in a table of 11. 120, 132. 11 12s are 132. Now 11 4s are 11 14s are 11 14s are, well, 11 13s are, we will get 143. So we are going to cut 143 also because it is divisible by now 13. So we are trying to find out whether the numbers can be divided by the prime numbers, because prime numbers, after that the number cannot be divided. Now next we have to check for, now we have checked for 11. Now we have to check for 13. So we will now try to divide the remaining numbers, which are 101, 103, 107, 1013, 127, 131, 137, 139, and 149 by any other prime numbers. Well, you try, you'll find that they are also not divisible by 17 and 19. So we will stop here, because we got all the prime numbers from 101 to 150. Circle them. So these are 101, then 103, 107, 109, then 113, then we are having 127, then we are having 131, 137, 139, and the largest three-digit number before 150, the largest three-digit number before, largest three-digit prime number before 150 is 149. So we will jot down all the prime numbers which are there from 100 to 150, which are 101, 103, 107, 109, then 113, then we are having 127, we are having 131, we are having 137, 139, and 149. So these are the prime numbers from 100 to 150. Well, we are now in next session use this idea of prime numbers for factorizing the composite numbers. Means how to find the factors of composite number using prime numbers in the next session.